Lines in context. When observed in real life, many types of data follow a straight line. For example, conversion graphs, velocity time graphs. The variables concerned may not be x and y, but we can consider them in that way. So below we've got an example where an experiment has been conducted and the variables b and c have been measured and recorded. And it's thought that the relationship connecting b and c is that c is equal to kb plus t. Plot the graph and find the value of k and t. So if we consider the equation c equals kb plus t, that's going to be similar to our general equation of a straight line, which is y equals mx plus c. So normally whenever we're looking at a set of values, we'd be considering them to be x and y. So we can see that x is equivalent to b and y is equivalent to c, which matches up with our equation. So that means the value of k is equivalent to the gradient and t is equivalent to the y-intercept. So if we will plot a graph where c is on the vertical axis and b is on the horizontal axis, then we'll be able to work out the values of k and t. So I've plotted the points and drawn the graph. So the first point was 1.3, 1.29, and 2.5, and 4.05, 3.9, and 7.27, 4.6, and 8.88, and 5.5 and 10.95, and I've drawn a straight line through as many points as I could. I tried to get the best straight line. So what we need to do is we need to work out the gradient, and to do that we need to pick 2 points, and we'll pick 2 points that are on the line. So we'll pick this one and this one. So the gradient is the y difference divided by the x difference, so y2 minus y1 over x2 minus x1, which is 10.95 minus 4.05 divided by 5.5 minus 2.5, which works out to be 2.3. Now the y-intercept we can't work out, so we can't work out the c, so we're going to have to substitute 2.3 into our c equation. So c equals kb plus t. We know k is the gradient, so it's 2.3, and if we use the 0.2, 0.5, 4.05, because that was one of the ones we used, the c value is 4.05 is equal to k, which was the gradient, 2.3. The b value was 2.5 plus t, and if we expand the bracket, so multiply 2.3 and 2.5 and take it to the other side, we get that t is equal to 4.05 minus 5.75. So 2.3 times 2.5 is 5.75. Take it over. We have to subtract it from 4.05, which gives us an answer of minus 1.7. So the equation then, connecting these two, is c equals 2.3b minus 1.7. And just on the t value has worked out to be negative, and that makes sense because the line, if we were to extend that down, it would cross the c-axis at a negative value. So everything's looking pretty good there. Example 10, a plumber uses this graph to work out how much to charge for jobs. What is a call-out charge? The call-out charge is the charge that he takes for just going to the house. To work that out, it's basically whenever there is the time he has spent is 0. So when t equals 0, that's the call-out charge, which we can see crosses the axis just above 20 and that's one small square above, so that's going to be £22 is the call out charge. How much for a 5-hour job? So what we need to do is we need to draw a line up from 5 and then go across to the y-axis, and we can see that that's going to be £100. How long will a job costing £110 take? So if we go from £110 on the y-axis and draw our line over to the graph, and then from the graph we draw it down, we can see that that's not quite 5.5, it's a little bit more. It's 1 square after 5.5, and there's 10 squares between for an hour. So that means 1 square is equal to 6 minutes. So then it's 6 minutes more than half of it. So it's going to be 5 hours and 36 minutes. What is the plumber's hourly rate? Well, what we can do is if we look at the cost for 1 hour and read it over, we can see that that is £38. So 1 hour is going to be £38, but that includes the call out fee. So what we need to do is if we take away the call out fee, which was £22, we can see that the amount that it is increased by is £16. And we could see that after 2 hours. So 2 hours we can see it's at it's at £54, which is an increase of £16 from the 1 hour mark. So everything looks good. So the hourly rate there is 16.